Okay. Okay, so I'm going to start probability today, and also we can organize a separate, we can devote basically one session maybe later, and that will cover maybe your questions, from different topics, let's say, whatever we cover. But today, let's start. Okay, somebody is asking for. Okay. Okay, so before we jump into probability, there are a couple of things which we need to understand. First thing which you need to understand is called fundamental principle of counting. Okay, what is fundamental principle of counting? So let's take a simple example. If you want to buy a car and there are, let's say, 3 models available, model 1, model 2, model 3, okay? And for each model, you have 3 options for 3 different colors, okay? So let's say green, black, and red. Green, black, red. Green, black, red. So in how many different ways you can select your car? So you can select, let's say, model 1 with green color, model 1 with blue color or black color, model 1 with red color. Similarly here, you have 3 options for model 2 and 3 options for model 3, isn't it? So how many total options you have? 9, isn't it? However, according to fundamental principle of counting, you don't need to do this, although this is a logical step. But without doing this, you can directly say you have 9 options by multiplying 3 with 3. 3 means 3 models available and 3 colors, isn't it? So 3 by 3 will give you 9. So you can directly tell how many possible outcomes are there, isn't it? Or possible ways are there to select a car. Another example we can take, if you go to the restaurant, let's say, and you have option for, let's say, 5 starters, and then let's say whatever 10 main course, and I will take 6, let's say, desserts. Okay, so in how many different ways you can make your meal? Okay, obviously you have to choose one starter, one main course, one dessert. So you can simply multiply 5 by 10 by 6, and that will give you 300. So there are 300 different ways you can make your meal according to the options available to you. Okay, so this is called fundamental principle of counting. Now, the second is in different types of experiments in probability related to your course, I'm saying they can give you question related to coins. They can give you questions related to dice, and they can give you question related to a pack of cards, isn't it? So how many cards are there? 52 in total, isn't it? In case of coins, how many options are there? If you flip a coin, you can get head or tail. But if you have two coins, how many outcomes are possible? If you flip two coins at the same time, you can get head on one coin and head on the second coin as well. Head on the first coin, tail on the second coin, tail, head, tail, tail, isn't it? Now, in order to write down the number of outcomes, you should follow a systematic approach instead of writing randomly. So I started with two heads, then I'm using one head, and then I change the position. So here head is your first, let's say first outcome on the first coin, and here it's on the second, and then I'm using two tails. Two tails means no head. Okay, so how many outcomes you have here? 4. Here 2. Similarly, if you have 3 coins, if you flip 3 coins, so you start with head, head, head. Okay, 3 heads, then you choose one tail. So I can write down one tail here on the third position, or on the second position, or on the first position. Okay, so this is for one tail. Then I can have two tails. So two tails together on the first and second position. I can have tail, head, tail, or I can have head, tail, tail, like this. And the last one is no head. No head means tail, tail, tail. So in this way, you will not miss any outcome because you're doing systematically, and the total in this case is 8. So if you have 2 coins, the number of possible outcomes is 2. So I can write down 2 as 2 to the power 1. 2 to the power 1. 4 I can write down as 2 to the power 2, and 8 I can write down as 2 to the power 3. So in case of coin, number of outcomes you can directly find out using this formula as well, which is 2 to the power n. N means number of coins. Number of coins you flipped. Although for 1 coin, 2 coins, and 3 coins, you can find out like this. But if I say you have, let's say 10 coins, you can directly say 2 to the power 10 is the number of outcomes. At least you know that what would be the final outcomes, isn't it? What number of outcomes. So 2 to the power n is the formula which is applicable for coins only. Okay, it will help you to get the total number of outcomes. Similarly, for the dice, how many outcomes you have? Obviously 6, everybody knows that. But if you have 2 dice, how will you make the total number of outcomes in this case? So again, you can write down 1 1, and then 1 1 means one number on the first dice and one on the second dice. Then you keep 1 as it is and change the number on the second dice. So 1 2 3 4 5 and 6. Okay, in the next row you start with 2 and then change the second number. Okay, in the third row you change to 3 and then keep 3 as it is and change the second number, isn't it? So in this way you can get the total number of outcomes for 2 dice. If you throw 2 dice, So I'm just writing the end 6, 6. So how many total outcomes are there? 36. 36 outcomes here, 6 outcomes here. So in this case, I can write down the first one as 6 to the power 1 and this one as 6 to the power 2. And based on that, I can generalize it to a formula 6 to the power n. This is the number of outcomes you can use for dice. 6 to the power n, where n is the number of dice. Obviously, they won't give you more than three dice, okay, in the question. So 6 to the power n is the formula for that, okay. Then you should know about the pack of cards, isn't it? So total number of cards are 52. And then we divide this into 4 categories, equal categories, let's say 13, 13, 13, 13. So you have heart and diamond, spade, what else? Anybody knows? What are the 4? Diamonds I already written. Clubs, yeah. Okay. So all of them are like equal in number, 13. And heart and diamonds, they are red, isn't it? These are black in color. So total there are 26 red cards and 26 black card. Then you have picture card, king, queen, jack, isn't it? So how many picture cards are there? These are called picture cards. So 4 kings, 4 queens, 4 jack, isn't it? So total is 12. So there are total 12 picture cards. Okay. So this is all about coin, dice, and cards. So if you know at least all these, you can tackle the question. Okay. Next is factorial. So what do you mean by factorial? In mathematics, we use a lot of notations, isn't it? Or symbols. So for example, if I say 2 to the power 3, so 2 to the power 3 is the notation for 2 by 2 by 2, isn't it? So in the same way we use factorial. 5 factorial, let's say. So what is the meaning of 5 factorial? 5 by 4 by 3 by 2 by 1. So 5 4 is 20, 20 by 3, 60, 62. So 120. So you can directly find out factorial using your calculator. But the meaning of factorial is, if I'm writing 5 factorial, it means 5 by 4 by 3 by 2 by 1. If I'm writing 3 factorial, it means 3 by 2 by 1, isn't it? Which is obviously 6. But there's another interesting thing here is I can write down 5 factorial as 5 by 4 by 3 by 2 by 1. But 4 by 3 by 2 by 1 can be written as 4 factorial. So I can write down 5 factorial as 5 multiplied by 4 factorial as well. In order to generalize this, n factorial can be written as n multiplied by n minus 1 factorial, isn't it? So 5 factorial means 5 multiplied by 1 less than 5 is 4 factorial. So similarly, n factorial can be written as n multiplied by n minus 1 factorial. Okay. Now there is a use of factorial in probability, which we will study now. But before we do that, there are questions. So one question, it was given in your exam paper. Let me take it out. Yeah. So I hope everybody has exam papers in front of them. So this is 2018 question paper 2018, question number 3. exam paper 2018, sorry. And it's part B I'm trying to do now. So they said n plus 3 factorial, n plus 2 factorial over n plus 1 factorial, n plus 1 factorial. This is the question, and this is equals to a n cube b n square c n plus d. So basically this is the general form of the cubic equation, isn't it? This is a cubic equation. So what they're asking is this, the factorial thing on the left hand side is equals to the cubic expression after simplifying, obviously. So you need to find out the value of a, b, c, d. In other words, you need to simplify this, and at the end you should get a cubic equation. Then you can tell what is a, what is b, what is c, and what is d. So the question is, how will you simplify this factorial? Anybody has any clue? Anybody has any clue about how to do these kind of questions? I presume a lot of people already did this chapter in school. This is your exam question. Any hint? No? Okay. So the idea is, in order to simplify and get the algebraic expression like this, you need to get rid of the factorial first. Okay. And the concept which I explain you here is what you need to use. Okay. So n factorial can be written as n multiplied by n minus 1 factorial. So this is the idea. So which one I should change? I should change a bigger bigger factorial. For example, n plus 3 can be written as, n plus 3 factorial can be written as n plus 3, n plus 2, n plus 1 factorial. Okay. So what we need to do, if you remember this example, 5 factorial can be written as 5 by 4 factorial. Okay. So let me explain again. 5 factorial means what? 5 by 4 by 3 by 2 by 1. I can write down 5 factorial as 5 multiplied by 4 factorial, which is this one. But I can also write down 5 factorial as 5 multiplied by 4 multiplied by 3 factorial, isn't it? Which is this one. Okay. So all you need to do is take away 1 and then you can write down the next one. Okay. Similarly, n plus 3. N plus 3 minus 1 is n plus 2, and n plus 2 minus 1 is n plus 1. So the next one is n plus 1. So I end up with n plus 1 factorial. Now why I end up with n plus 1 factorial? Because I can see n plus 1 factorial in the denominator. Okay, so let me remove this first. So I can see n plus 1 factorial in the denominator. Similarly, n plus 2 factorial can be written as n plus 2, and next one should be n plus 1 factorial. What's the benefit of this? Benefit of this is I want to eliminate the factorial terms so that I can simplify. How to eliminate? So now I can simply cancel the factorial term. So what you need to do? You need to pick the bigger number, okay, reduce it to the smaller factorial, which is generally given in the denominator, okay, or vice versa. They can give you bigger number in the denominator and the smaller number on the numerator, okay. And now you can see that you only left with n plus 3, n plus 2, n plus 2. And since I do not have any factorial left here, so I can simply multiply. And since you have 3 factors here, okay, you should get a cubic equation. So let us solve this one by one. So n plus 2 multiplied by n plus 2 will give you n square plus 4n plus 4. You can do step by step, but that's the answer. And then let us multiply n plus 3 as well. So n plus 3 multiplied by this means you multiply n first to the second bracket, and then you multiply 3 to the second bracket. This is how we multiply two brackets. And then this will give you n cube, 4n square, 4n, 3n square, 12n, 12. So n cube plus 7n square plus 16n plus 12. What we got is a cubic equation. And what was the right hand side there? Right hand side was an cube, bn square, cn plus d. So now you can simply compare and write down the value of a, b, and a, b, c, d. So a is 1 because the coefficient of n cube is 1. Coefficient means the number beside n cube. Number beside n square is 7. So b should be 7. Number beside n is 16. So c is 16. And the constant number is d, which is 12 here. So d is 12. Okay. So the important part of these kind of question is you should know how to write down, for example, 5 factorial as 5 multiplied by 4 factorial. So in general, it's n factorial equals to n multiplied by n minus 1 factorial. Okay. So you need to get rid of the factorial and then you can simplify. So these kind of questions they can ask you. Okay. Okay, let me see the next type of question here. Okay, so the next part is permutation and combination. So permutation means arrangement and combination means selection, so which we will study after this. So what kind of questions they can ask you, and first of all, what do you mean by permutation? Okay, it looks like permutations questions are not given, but anyway, let's understand this. So they can give you some numbers, let's say 1, 2, 3, 4. So you have 4 numbers, okay, and you want to write down a 4-digit number, okay. So how many 4-digit numbers you can form using 1, 2, 3, 4? For example, I can say 4, 3, 2, 1. I can say 2, 3, 1, 4. I can say 4, 2, 1, 3, something like this. So in this way, how many numbers you can form, 4-digit numbers you can form using 1, 2, 3, 4. Okay. Now, what's the use of factorial here? We can directly say it's 4 factorial. But what is the logic behind that? So if you understand the logic, you will understand how we are writing this directly. So you want 4-digit numbers, make 4 places. Okay. Start from the first one, from the left. For the first place, how many options do you have? You have 4 options. You can choose any number out of 1, 2, 3, 4. So you have 4 options for the first place, isn't it? So I'm writing options here, okay, not the numbers. Options. For the second place, how many options do you have? 3, because you already chosen one number for the first place, so you have only 3 options left. Then you have 2 options left, and then you have only 1 options left, and then you multiply. So 4 by 3 by 2 by 1 is actually 4 factorial, isn't it? This is more logical way of doing it, and sometimes this is helpful. You may not be able to write down 4 factorial directly in some questions, okay? So that's why this is very important to understand the logic. But for this question, we can use 4 factorial. Now, the confusion starts when we start using this formula, which is NPR, okay? Now, it is given in your scientific calculator, this NPR. So you press, for example, I want to find out, let's say 5 PR. So you press 5 in your calculator and press this symbol, and then you press whatever number you want, 5P3, let's say. So 5P3, and this will give you the answer, isn't it? So you know how to find out this. But this is the formula for finding the number of outcomes as well when you are arranging numbers. So the confusion starts when to use this formula and when to use this factorial. Anybody has any idea how will you decide whether you need to use the factorial or this NPR formula in the question? How will you decide? Anybody has any clue? Because that's the point where students struggle after reading the question. Any idea? If you, Anna said, if you have conditions, what type of condition you are saying? You can switch on the mic. Specific placements. Not very clear. Anybody else? Okay, so let us understand the difference. And it's very simple actually. If you have 4, let's say, objects, I'm calling this object. Objects means it can be a number, it can be a letter, or it can be anything, whatever you want to use. If you have 4 objects and 4 places or positions, you can directly use factorial. However, if the number of objects are not equal to number of places, available places, then use NP or formula. So N is for number of object and R is for number of places. That's it. That's a simple, straightforward logic which you need to use. So if you have, so I give you this example of 4-digit number. How many number I give you? Numbers, 4 numbers. And how many places? 4 places, because I said write down 4-digit numbers, isn't it? So 4 objects, 4 places, you can directly use the factorial thing. But if you have number of objects which is generally greater than, so for example, I gave you number, let's take an example, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many numbers I gave you? 9. But I don't want 9-digit number from you. I want only 5-digit number from you. 5-digit number. How many 5-digit numbers you can form using these numbers? So how many objects you have? 9. How many places you have? 5. So 9p5 is your answer. And obviously you can use calculator to do that. Okay. Sophia said arrangements. Well, this is all arrangement, doesn't matter how many objects, how many. So whenever they say arrange these numbers or form a number, you are actually doing arrangement. So that's not the key thing. You have 5 books and you want to arrange 3. Yes, that's correct. Okay, this is what I'm saying. So if you have number of objects, which is obviously greater than the number of places, then you can use this formula straight away to find out your outcomes. Okay. Now, there are different types of questions, although I couldn't find out any particular question related to permutation here. Let me check quickly again. There is a question. Oh yeah, I think it's here. Yes, it's same 2018 paper, question number 3, part A. Okay. A security code consists of 6 digits chosen at random from the digits 0 to 9. So 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the security code which they are using is a 6-digit number. Okay. And they give you example. So this is just an example given in the question. 071737 is a valid code. So one thing you can notice here is that 7 is repeated in the code, isn't it? Generally we don't repeat, but this is another thing. Now let's see what they're asking for. Find how many of the possible codes will end with a 0. How many of the possible codes will end the 0? So how will you do this question? Any idea? So they are saying will end with a 0. So the last place is 0. Okay. And how many places left? You have 5 places left. 1, 2, 3, 4, 5 left. But the last one should be 0. So how will you find out the different possible codes? Ten to the power 5 by 1. 10 to the power 5 by 1. Yeah. 10 by 10 by 10 by 10 by 10. Why? So if you see, that's why I said if you just learn factorial and NPR, you won't be able to answer, and that's the confusion starts. So what's the logic behind this question? Okay, or this type of question. So start from the first place. Okay, starting from the first place. So how many options do you have? 1, 2, 3, 4. You have 10 options. Okay, you have 10 options for the first place. Then you have 10 options for the second place as well, because they did not say that repetition is not allowed. They did not say that in the question. So you have to read the question carefully. If they say repetition is not allowed, then it's a different story. But at the moment they didn't say anything, so you can repeat, and that's why they give you this example as well. And as I said, 7 is repeating here, so you can repeat any number of time. So for the first position you have 10 options, and it's a code. It's not a number, it's a code, so it can start from 0 as well. Okay, that's another tweak here. This is 10, this is 10, and this is 10 as well. Okay, so 10 by 10 by 10 by 10, which will give you 10 to the power 5. Now why we are saying multiply by 1? it is not going to change the answer, but why we have to say 10 to the power 5 multiplied by 1? And the reason for that is this is 0 at the end, isn't it? And you have one number. Obviously, if you have one number, then it's fixed, okay? But why we are saying multiply by 1, I'll explain you with a second example within the question, okay? Let's say I change this question a little bit, and I will say the last two digits would be, let's say 1, 2, last two digits, and then the remaining are 4, isn't it? So I fixed these two numbers at the end, and then I'm asking you the same question, how many possible codes you can form. So you will say, for the first place, you have 10 options. For the second place, you have 10 options. For the third place, you have 10 options. For the fourth place, you have 10 options. Okay. So you will get 10 to the power 4. But this time, I will multiply this by 2 factorial. Now, why 2 factorial? Because within this box, the fixed box, I can interchange 2 with 1, because the question is I want to keep 1 and 2 at the end, okay, until unless they say no, it has to be 1 2 at the end, but it can be 1 2 or 2 1, isn't it? So there are two possibilities. It can be 1 2 or 2 1. So two possibilities means 2 factorial. And in the previous question there was only one number, so that was actually 1 factorial, okay, which is 1, okay. But the reason I am telling you to use factorial here, because if I further change this question to, let's say 3 1 2, I want to keep them as the last three digits. So this time you would say 10 10 10, but multiply by not 3 factorial. That's why I'm adding factorial here, because it's not just 2, although 2 factorial means 2, but you need to still put 2 factorial, and then in the next step you can say 2 multiplied by whatever 10 to the power 4. But there is an importance of use of factorial here, because 3 1 2, you have three numbers here, but you can change their position as well. In how many ways? In 3 factorial ways. Why 3 factorial ways? Because 3 factorial means you have three numbers, which is 1 2 3, and you have 3 places for them. So how many ways you can change their position or form 3 numbers, let's say, using 3 factorial ways. So that's why you have to multiply by 3 factorial here, 2 factorial. For this question, even if you write 10 to the power 5 multiplied by 1, it's fine. But if they say two numbers at the end, which you can basically change their positions as well, so it's 2 factorial. Again, 2 factorial will give you 2 as an answer, but according to the logic of probability, it has to be 2 factorial. And similarly here, it has to be 3 factorial. So there are a lot of questions in your book you see where they, say that these two letters must be together, these two numbers must be together. So there you need to be careful. Okay, there is a second part of this question. Second part of the question, find how many of the possible codes will contain the digits 2018 together. Well, this is what I was explaining you, and they ask you now. So, and they said 2018 together and in this order. So you cannot change the order. Okay. So how many of the possible codes will contain the digits 2018? So what you need to do is you can write down 2018 anywhere, doesn't matter. And how many spaces left? 2 spaces left, isn't it? And put this into the box. This is in the box. And in this box, 2018, you have to keep the order. So what do you mean by keep the order? Keep the order means I cannot change their positions. Okay, so I cannot write down as 4 factorial. Do you understand? because I can't change their positions within the box. Okay, so how many places are left now? You have 2 places left. So 2 places left means 10. First of all, 10, isn't it? 10 by 10. But this 2018 box, I can move here and there, isn't it? For example, I can write down 2018 here, isn't it? And I can say, sorry, this is not there. Yeah, so I can say this is 10 options for this, and this is one option, isn't it? So 2018, you can move from one place to another. Okay, now how will you get the answer in this case? So first of all, 10 by 10 is 10 square. So here also you will get 10 square, isn't it? But how many ways you can change the position of 2018? So you need to say this is one position, this is one position, and what's the next position you can make? There are only 3 positions possible, isn't it? So I can write down 2018 here. So I'll get 10 here, 10 here as well. So which is 10 square, isn't it? So there are only 3 possibilities. So plus plus at the end you can add all of them, or you can simply say 3 multiplied by 10 square as your final answer. Okay, so this is the logic behind permutation and factorial. Just to summarize this permutation part, so if number of objects equals to number of places, you use factorial. You can use factorial. But again, I'm saying you should know the logic behind how to write down the options for each of these places. Okay. Obviously, after reading the question, they can give you a lot of different ways of asking the question. So you need to read the question carefully, whether they are fixing some number at the start or they are putting, let's say, 2 numbers together. So different ways they can ask you. I hope it covers everything. Okay. Now, next thing is called combination. Combination means selection. Now you don't need to worry about when to use permutation, when to use combination, because you will see selection word in the question. They will say selecting or selection of this and that. So selection will be there. And what's the formula for combination? It's NC or. N means number of whatever objects, and this is your selection basically. Okay, so you are selecting R objects out of N objects, let's say. Okay, now what type of questions they can ask you? So let me pull out. Yeah. Um, okay, so I don't see any particular question on this. Anyway, so let me give you an example straight away. So let's say you have 10 boys and 8 girls. Okay. And you want to make a team of, let's say, 11 people or 11 students. So you want to make a team of 11 students. Okay. So how many different ways are possible? So you can choose 10 boys from 10 so 10 students from 10 boys, let's say. And how many students left? 1. So you can use 1 girl out of 8, isn't it? So that will give you one answer. Okay. And you can also choose 5, isn't it? 5 students out of 10 boys, let's say. And you can choose 6 students or 6 girls out of 8 girls. So that will give you the answer for that. Now, but they will put some restriction. They will say there should be, let's say, 5 girls in the team. Okay, 5 girls in the team means you say 5 out of 8. So 8C5. And how many students left? 6. So 10C6. And that will give you the answer. Okay. So this is how you need to use combination. Okay, now there is a question there, but it requires probability. So maybe I'll directly, the next topic is the probability. So how to get the probability? What is probability? Probability means what is the chance of occurrence of some or any event, isn't it? So we say, oh, there is a 50% chance. So that 50% is basically we are saying about the probability. But how will you define mathematically? So mathematically, number of, let's say, possible outcomes or number of favorable outcomes over total outcomes. So that will give you the probability. For example, I want to find out the probability of getting, so let's say I flip 2 coins. I want to get the probability of getting 2 heads. 2 heads. 2 heads means 2 head. So there is only one outcome which can give me 2 heads, and total outcomes are 4. So 4 outcomes. How I got 4? Because there are 2 coins. So 2 square is equal to 4. So I know that for 2 coins, the total outcomes are 4. So the probability is 1 over 4 for head basically. Okay. Similarly, what is the probability of getting one head, or I should say at least one head? Now, if I use the word at least one head, it means it can be one head, it can be 2 heads, isn't it? So at least one head. So at least one head means head tail, or tail head. These are the 3 outcomes, isn't it? 3 out of total is 4. So 3 over 4 is the probability. Probability, the value of the probability, whatever you're getting, should be between 0 and 1. So if you're getting probability, let's say by mistake, more than 1, it's wrong. It cannot be more than 1 because 0 the minimum value of the probability is 0 and the maximum value is 1. Why? Because whatever is your probability, let's say the probability is 1/4. Okay, if you multiply this by 100, you will get answer in terms of percentage. So it means 1 means 100% probability, isn't it? And 0 means 0%. So you cannot have a negative answer for the probability, and you cannot have an answer greater than 1, because 1 means 100%. So you cannot have more than 100% chance, isn't it? So this is the range of probability, and if you multiply by 100, you will get answer in terms of percentage, like 25% or 75%. So that's the basic formula for probability. Now, there is a question here, 2011, paper 2011, question 1, B part. Okay. In this question, there are 16 girls and 8 boys in a class. 16 and 8. So obviously the total students, I can write down the total as well. So total number of students are 24. So now they are saying half of these 24 students study French. So which means 12 students study French. So first write down whatever is given in the question. The probability that a randomly selected girl studies French is 1.5. Okay. So probability of a randomly selected girl studies French is 1.5 times the probability that a randomly selected boy studies French. Okay. So this is given. How many of the boys in the class today study French? So you need to find out basically how many boys study French and how many girls study French as well. So any idea how will you do this question? So total 24 students are there and 12 students study French, but we don't know how many girls, how many boys study French in 12 students. So how will you answer this question? Any idea? Okay. In mathematics, always you have to use what is given in the question. So what is given in the question? This, the probability of selecting girl is equal to 1.5 times probability of selecting boys. So let's say there are X number of boys. We don't know how many boys are there who study French, but you don't need to assume Y here, Y for girls, let's say, because always try to limit the number of variables in mathematics. So I know that total number of students who study French is 12. So I can write down 12 minus X for girls, isn't it? And now I want to write down the probability of selecting girls. So 12 minus X is the possible outcomes, and the total outcomes are 16. There are 16 girls. That's the probability for selecting a girl who study French. 1.5 times probability for the boy. How many boys study French? X, we don't know, but the total number of boys are 8, isn't it? So this is how you need to form an equation, and then you can simply solve this. So how will you solve this? So 8 2s are 16. 2 multiplied by 1.5 will give you 3. 3x. So 3x plus x equals to 12. 4x equals to 12. So x is equal to 3. Okay. So 3 boys study French, and 12 minus 3 is 9 girls study French. Okay, so these type of questions they can ask you. So that is related to the probability, and they can give you these kind of conditions to do that. Okay, so that's one thing. Okay, now if you studied set theory properly, you can answer these type of questions. So this is question number 1, paper 2010. What is the question? Two events A and B are such that probability of occurrence of A is 0.2, probability of A intersection B is 0.15, and probability of A complement B intersection B is 0.6. So first part of this question is complete the Venn diagram. So they give you a Venn diagram and you need to complete that. So they just give you 0.15 here. This is A, this is B, and S. S. Now in set theory you call this rectangle as a universal set, but here we call this as a kind of sample space. You can say sample space. Sample space, which means it covers total outcomes or probability, you can say. So 0.15 is given. So where is 0.15 in the question? This one, A intersection B. So in set theory, you know that intersection means common area, which is this one. So that's already given in the question. But how will you write down the remaining part? Okay. So remaining part means this part. What is this part? How will you define this part? So this part is actually probability of A, which means the total, and then you need to remove the intersection part from this, isn't it? And that will give you, so I'll just shade this with a different color. So that will give you this part, isn't it? Probability of A means the total, let's say, circle, minus the green part, which is A intersection B, and this will give you answer for this part. So P of A is given 0.2 minus this is 0.15. So the answer is 0.05. Okay. Similarly, how will you get the other part? Now, they did not give you probability of B, isn't it? But what they give you is A complement intersection B. So first of all, what do you mean by A complement? So I'll just draw it here. Let's say, let's imagine this again. This is A, this is B. So A complement means anything outside A. Okay. Outside A. So let me draw this first. So this is A complement. Okay, so that's A complement. And where is B? You know B. And they said A complement intersection B. Okay, so I hope it is visual. Okay, let me use this one. Yeah, this is better. So A complement intersection B. So what they give you actually this part. Okay. So that is your 0.6. That's 0.6. So we got this one, which is 0.05, and that's 0.6 and 0.15. So how will you get the outside part? Now the total probability is always 1. Okay, so total probability is always 1. So 1 minus, you add all of them, 0.05 plus 0.15 plus 0.6. Okay, so which will give you 0.2. So this is 0.2 outside A and B. Okay, so this is how you need to complete the table. And if you know the concept of set theory, it's very easy. And the B part of this question is find the probability that neither A nor B happens. So which we already got it, which is 0.2. So this is basically the answer for part B. Okay. Neither A nor B means it's outside that. Now conditional probability, which we need to cover later. I don't want to right now. State whether A and B are independent events, so which we need to cover the next time. So that's the idea behind this. Okay. So I would say I don't know what you're writing, Leonardo da Vinci. Is that you? Okay, so you need to practice permutation, combination, and factorial questions like that. I think you have 2 chapters, isn't it? So pretty much you can practice all this permutation, combination, and outcome-based questions based on arrangement and selection, that kind of stuff, factorial. Okay, so next time we will cover questions related to expected frequencies or expected values and all. Okay. Okay, so I'll see you guys next week. And if somebody needs grinds on physics or chemistry, we are starting group sessions as well this week at a discounted rate, obviously. So if anybody interested, you can let me know. Okay. For physics and chemistry as well. Okay. Thank you. Bye.